In this video, we'll see an example for partly nested design, and we will analyze the data and explain the results in the context of the problem. And this is a very similar analysis when you have fully nested design, a split plot, repeated measures, sampling, subsampling, mixed model with both fixed and random factor. So this will be very helpful if you are doing an advanced level statistical analysis and explaining the results. So here is a very typical scenario for a partly nested design. Now, we really don't need to know what the name of the design is. Is it partly nested or split plot? That has nothing to do with the analysis. The analysis is guided by three things: whether the factor is fixed or random or nested. So all we have to do from this big explanation is to find out these three, nested factor. So we have these four factors here: institution, and then instructor, course, and method of instruction. So all we have to do here is to determine these different types of factor. What are they? Fixed? Are they random or nested? That's what we need to do. First thing we need to determine is the nested one. So let's look for, we read through it and see. Generally, instructor is nested under institution, like leaves is nested under tree, something like that. Trees are nested in the forest. Different fishes or species of fish nested in a lake or rivers or something like that. So that's kind of universal, that instructor is nested within institution or in institution. Let's keep reading. So now courses could be nested under instructor. The instruction method could be nested under instruction, but that depends. Let me see. Let's keep reading it. So it says that currently only 2 instructors are offering the DOE and quality courses in institution. Now it says only 2 instructors. So that fixed. It would be a random factor if we have selected 2 instructors from, let's say, out of 500 instructor. We randomly pick only 2. We didn't do that. It says only 2 instructor X and instructor Y. They can only teach the DOE and quality course in each of these schools. So then this is a fixed factor. Instructor, that's a fixed factor. We know that now. Now, course, you have only DOE and quality. So again, only 2. You're not selecting 2 courses from a list of 200. We are only talking about the DOE and quality course. So that is also a fixed factor. So you're almost there. Method of instruction, you can see here that there is only 2 method of instruction: online and face-to-face. You're not selecting 2 method of instruction from a list of 500. There is only 2 ways these 2 courses are taught: online and face-to-face. So that's fixed as well. So this one is fixed. Now for the institution, typically for a nested design or repeated measure, these are usually typically a random factor. It also says here 2 master's granting institution right here. Master's granting institutions randomly selected. Now random is within parentheses. So what I'm going to show you here is we'll analyze the data in both ways, in using both treating the institution as a fixed. Let's say you're only talking about institution X and institution W. So in that kind of situation, that would be a fixed factor. However, if you randomly select 2 institutions from a list of 50 institutions, then that would make this institution factor random. So we'll do both and see, compare the results and see. Really interesting result we'll see. Couple of more things. As I said, that course can be nested under instructor can be instruction method can be nested under instruction. But if you read this couple of sentences here. It says, no, they don't treat them as a nested factor, treat them as a cross factor, meaning that they're not nested. So when levels are very similar, exact same, they can be treated, they can be crossed. So we don't have to treat them as a nested factor. We only treat them as a nested factor when the levels are not similar, like instructor X is a different person than instructor Y. But online type of method, if it's very standardized, all school does the same, then it doesn't matter you take online classes from here or there, if they would be the same thing. So in that kind of situation, it doesn't have to be nested. So we understand all these definitions. So institution, we will, as I said, will treat both, first analyze as a fixed, and then we analyze as a random factor and compare the results. So let's copy the data in Minitab. I did it already. You go to Stat, ANOVA, Generalized Linear Model, performance is the response here. I have 4 factors, A, B, C, D. E is not a factor, random nested, we'll keep everything same, fixed, and then B, instructor, is nested in A, so we'll select A beside B, hit OK. Model, we'll select all the interaction. We have enough replication to do that. So as you can see here that C and D are observed to be significant, so we'll have to run the post hoc analysis. Go ANOVA, Generalized Linear Model, comparison, just run post hoc analysis for C and D, hit OK. I have copied all this result in the PowerPoint right here, treating all of them fixed factor. As you can see, the course is significant. So, and also the delivery method is observed to be significant. So course 1 was quality. The level 1 was quality, and then 2 years DOE. So it looks like that a student performs significantly better in quality than DOE. They get about 5% consistently more, much better performance in the standardized test than quality. Delivery method, 1 was face-to-face, 2 was online. It looks like students who take that classes in face-to-face, they perform significantly better than those who take online, about over 5% more different. Now let's run that institution as a random factor and see what we get. Stat, ANOVA, Generalized Linear Model, just select that institution a random factor, which is A is a random factor. That makes B random by default because the B is nested in A. So here is the result. I have also copied the result in PowerPoint here. You go to the next slide. So here is every A is treated, institution is treated as a random factor. Now you can see this interesting thing. When we treat A as a fixed factor, there was a significant difference between the quality and DOE courses. And also there was a significant difference between the face-to-face and online method of instruction. Now it's not significant anymore. So, and let's see if we try to understand this. If you are treating A as a fixed, meaning that you're only looking at just 2 institutions, so there will be less variability just in 2 institutions. However, when A is a random factor, which means you selected 2 institutions from a list of 50 institutions, for example, and now you are trying to generalize the findings across all 50 institutions. So you need a little bit more robustness into that generalization. And also because of this randomness, you selected this factor randomly, there will be more random error. So it will be difficult to find significant, not difficult, you need a little bit more robust information to say, yes, the students are doing better in an online or face-to-face method than in online. So something that you will find easily significant in fixed factor model, in the random factor model, you might not which makes sense. There are a couple of things here. It says it cannot produce the exact F statistics. So in the next video, I'll show you how to find this approximate F statistics, basically some numbers here and here. We have also shown this in the earlier module in the expected mean square section as well. However, for this video, just to summarize, as I said, if I go back earlier, you really don't have to look at which type of design is it. Is it repeated measure, split plot, sampling, subsampling, what this thing called? It has nothing to do with analysis. All you have to do in analysis, basically you determine, is it a nested factor first, and then you try to determine, is it random or fixed, and then the analysis will be guided from there. So it's just simple as that. Don't have to be scared by looking at the name of the experiments. So just read this carefully, try to determine what exactly that type of variables they are, and then you can select that in the software, whatever that appropriate if it's fixed, just select as a fixed. If it's random, select as a random, and so on. So I hope that clarifies that this confusion of analyzing this advanced design of experiments.